Filoplumes, the unsung heroes of bird flight for decades, scientists dismissed them as evolutionary leftovers. But new research suggests that Filoplumes' tiny, hair-like feathers at the base of flight feathers are critical for birds' ability to fly. These nearly invisible structures are now understood to be essential for feather maintenance and flight stability. The history of neglect curator Vanya Gregor-Rower of Cornell University's Museum of Vertebrates demonstrates the overlooked nature of Filoplumes. Even displayed on a vibrant roseate spoonbill wing, they are easy to miss. For years, Filoplumes were considered degenerate or useless, relics of avian evolution. This is not unusual. Many biological structures once dismissed as vestigial have later revealed critical functions. How Filoplumes work. Dr. Rower, along with his father, Sievert Rower, a renowned feather researcher, argues that Filoplumes act as sensory monitors for feather position. Because flight feathers wear over time, these sensors allow birds to adjust their wings for optimal aerodynamics. All 6 types of feathers on a bird's body are made of keratin, the same material as human hair and nails, but Filoplumes stand out due to their unique sensory role. A 150-million-year-old evolution, Filoplumes have been evolving alongside feathers since the first dinosaurs took to the skies roughly 150 million years ago. Their existence underscores how even seemingly minor features can be essential for survival and adaptation. The rediscovery of Filoplumes' importance highlights a crucial lesson. In biology, dismissing a structure as useless is premature. Every component of an organism has likely evolved for a reason, and understanding these functions is key to unraveling the complexities of life.